Today we will work on two very important functions. For your 4.2 and 4.3 notes, we will talk about exponential functions and log function. The exponential function, the general form is y equals a to the power of x. And the inverse function of this is, of course, we get to switch your x and y. I will say therefore that x is equal to a to the power of y. In order for you to get y alone, you need to apply a little formula or a little trick that I usually call drop the base and switch, but you will get it in a minute. That's log base a of x is equal to log base a of a to the power of y. In other words, I apply the log base a to both sides. By applying the log base a to x, this nothing will cancel on the left side, but log base a of a is actually equal to 1. So I will end up with y is equal to log base a of x. When you travel from this to this is actually the inverse. These two functions are inverses of one another. All right, let's go ahead and look at the general graph or the parent function of the log function versus the exponential function. You should know this by now. Let's start with log of, no, let's keep it together. Log of x here. And this is a to the power of x. For a to the power of x, the exponential function will come like this and rise. Compared to the log function comes from the bottom, it travels like this and rises. Now, this point is the point 1, just like this point is also 1. Let's talk about domain and range, starting with the domain. The domain of your exponential function starts from 0 till infinity. Actually, it's from negative infinity till infinity. It's the range that is from 0 parenthesis till infinity. And this function, whether you look at it from any side, is going to be a function. The inverse is also a function. So the function is known to be 1-to-1. This is also 1-to-1. And let's talk about the domain. The domain here is from 0 till infinity, and the range is from negative infinity till infinity. Note that since they're inverse, the domain of the first one ends up being the range of the other, and vice versa. Here I will say, if x is equal to a to the power of y, then y is equal to log base a of x. Both ways work. So I can go this way and also say if, going back this way, y is equal to log base a of x, then x is equal to a to the power of y. The right way to, instead of then, I could have just put the equivalent symbol in between them. Let's do one simple example. Here's my example. I will say log base 2 of 8. Log base 2 of 8 normally is equal to 3. This means that 2 to the power of 3 is equal to 8. How do I know log base 2 of 8 is equal to 3? In fact, a is 2 to the power of 3. So I will have log base 2 of 2 to the power of 3. Log base 2 of 2 being 1, this whole thing will cancel, giving you the 3. And if we go both ways. Let's do another one. What if I say now that I'm going back to the same one, but I will say this time 2 to the power of x is equal to 8. Well, this tells me that x is equal to 3, right? So if I say 2 to the power of x is equal to 7, how will you get the answer? You will actually say log base 2 of 7 will give you your value of x. And of course, you will use your calculator or your log table to get this. But the calculator will be my first route. Little problem. Let's go ahead and evaluate the following. Log base 3 of 27. What is this equal to? Well, the easiest way to solve this is to transform it as 3 to the power of x is equal to 27. And from here, 3 to what power is 27? That's easier, and you will say x is equal to 3. I can just say also log base 16 of 4. Find the answer. In other words, you will say 16 to the power of x is equal to 4. Well, 16 to what power will give you 4? That's actually 1/2. That's the square root. One last one. Last one, I will say log base 3 of, now let's do something different. Log base 7 of 1 over 49 is equal to what? In other words, you will say 7 to the power of x is equal to 1 over 49. Well, at this point, to get 49, you need square. To be on the bottom, you need a negative. So x is equal to -2. These are easier way to solve log functions. All right, let's go ahead and continue. I'll put a line through this. Let's talk about common, missing an n, common log function. I have log base a of x. When a is equal to 10, that's your standard. It's called standard base because that's what the calculator knows. That's all the calculator knows. If you don't put the base on your calculator, it's doing log base 10. Now, natural log on the other hand, natural log is actually labeled as ln of x, and ln is nothing other than the log base e of x. E is the exponential number. It's a number just like pi. It's on your calculator as well. Now, what would you say if I asked you to find log base e of e? Of course, it's 1. Log base anything, if these two are matching, it will be 1. I will give you some few tricks. Let's evaluate few stuff. Let's start with log of 100. A log of 100 is equal to 2 because it's actually log base 10 of 10 squared. And the 10, since they're matching, is just the power, which is 2. Natural log of e. What's the natural log of e? Natural log of e is 1 because remember, natural log is log base e of e. Since they're matching, you will call it 1. Natural log of 1. This is by convention, the natural log of 1 is 0. This is a must know. What about the natural log of 1 over e squared? Well, the natural log of 1 over e squared is the same thing as the natural log of e to the power of -2. Well, natural log of e is 1, so this is nothing other than -2. What about log of 10 to the power of 5? Log of 10 to the power of 5 is actually equal to 5. Why? Because the log of 10 is actually log base 10. We just don't write this 10. And the 10 matching, the answer is 5. Here are a few things you need to memorize. Log base a of 1 is always equal to 0. So is the natural log of 1. The log base a, and I've said this so many times already, of a, when these two are identical, is equal to 1. So is the natural log of e. I can also say that the log base a of a to the power of x is equal to x. So when these two are identical, it's just the power. So is the natural log of e to the power of x. It will just be x. One last one. If I say a to the power of log base a of x This is nothing other than x. And it works also when you say e to the power of natural log of x will just be equal to x. This is a huge summary. If I were you, I should know this. Very important. All right, let's go to a slightly different domain. Let's find the domain of, this is like your 4.3, by the way. Find domain of f of x, knowing that f of x is equal to the natural log of 4 minus x squared. Remember, the natural log, you cannot find the natural log of a negative number. So the first thing you will say is 4 minus x squared is greater than 0. By the way, natural log of 0 is undefined. In other words, you cannot find the natural log of any number less than or equal to 0. So if you solve this one, you end up with 4 is greater than x squared. That means the domain is between -2 and 2 with parentheses because you don't want it equal. All right, let's get to 4.3 now. Don't worry, we're almost done. 4.3 is all over logs. Log base a. Maybe I should write in green. The log base a of xy is equal to the log base a of x plus the log base a of y. So the product turns into the addition when you split them. Now, it works just like the power rule. Remember, when you have the product of two with the same base, like a to the power of m times a to the power of n is equal to a to the power of m plus n. Kind of similar. So log base a of x over y. If you find again similarities with the power rule, it will be therefore log base a of x minus log base a of y. Now let's do the big one. Log base a of x to the power of k, k being a number, is nothing other than k times the log base a of x. Let's do a simple example right here on the left side. I will ask you to expand this. Log base 5 of x cubed y 6. First of all, I will split them into log base 5 of x cubed plus log base 5 of y to the power of 6. And then from here, you can say it's 3 times log base 5 of x plus 5 times log base 5 of y. Let's keep going. If log base a of x is equal to log base a of y, therefore I can say x is equal to y. Now let's go ahead and condense something. We just expand earlier, now I'm condensing. Let's condense 3 times the natural log of a plus 1/2 the natural log of b minus 4 times the natural log of a squared plus 1 minus natural log of c. One thing you need to remember, the first thing I would do is push all these factors back in. So this is natural log of a to the power of 3 plus natural log of b to the power of 1/2 minus natural log of a squared plus 1 to the power of 4 minus the natural log of c. The next thing to know is every single positive values, positive natural log will remain on top and negative natural log will go to the bottom. So this is a big natural log of the positive one will go on top and it will go back as a product. And the negative one, we go on the bottom also as the product. And that will be your final answer. All right, I'll keep going. Find the, by the way, you should know how to evaluate. So let's say I ask you this. Log base 2 of 80 minus log base 2 of 5. You should first be able to reduce this. 80 is what? Well, you can break it into pieces. And if you evaluate this one, you should end up with, I'm going to leave it up to you. Again, you can use the calculator here, but before I go any further, or before I end this, I will show you one last thing. I can ask you to solve for P. And to solve for P, I will say log of P is equal to log of, let's say, P naught minus C log of T plus 1. And I ask you to solve for P. In order for you to solve for P, you must first condense this side. So I will say log of P is equal to a single log of P naught over P plus 1 to the power of C. And at this point, I will apply the exponential to both of them. I will raise each of them. I put the exponential on both. Then E and log will cancel, leaving you with P is equal to P naught over T plus 1 to the power of C. And that will be your final answer.